Wildguard is a web application that is intended to solve a long-standing problem with animal conservation, that being difficulty with collecting animal population data. This is done by inviting users to upload animal sightings that are then applied to a map and then used to determine animal population ranges, which can then be used to estimate populations.
My name is Alex. I'm going to be covering the non-logged in view. So from the non-logged in view, we can access pages such as species search, about us, and interactive map, just for demonstration. If we try to access reporting an endangered species sighting, we're asked to log in. This is the same for our machine learning pages. And then these are third-party links to third-party organizations such as the World Wildlife Fund that have websites almost as good as ours.
Hello everyone, my name is Megan and I'm going to be demonstrating one of our two user roles on our website, the volunteer role. Volunteers are able to upload sightings to our page, view our map, and also utilize our machine learning model to classify their photo, which Derek will be demonstrating. So first I'm going to demonstrate creating a volunteer account. To do this, we can just enter any valid email and fill out the form. And don't select this because then we'll create a researcher account and it will require a .edu email to be affiliated with the university. Once we register, we can log in with our new volunteer account. And once we do this, you can see the navigation bar expands to accommodate the additional functionalities that volunteers are able to see. So the first thing we're going to look at is the interactive map, and this is where people are able to view all the different sightings that have been submitted from our site and gain geographical insight on where endangered species might be located. We're going to focus on the sightings. You're able to filter by species. We're going to look at the red wolf today, and we can see two sightings have been submitted about the red wolf. So let's say I'm out hiking and I see a red wolf and I want to report a sighting. I can come here and add that, add the species scientific name, as well as the date that I saw it and the location that I saw it. I'm not exactly sure where red wolves live, but we'll input some random coordinates for demonstration purposes, as well as a photo of our species. When we submit a sighting, we're taken to the map page again, where we can filter by the red wolf, and we can see 3 sightings now submitted instead of 2. And researchers and volunteers can use this data to learn more about the species and where people are seeing it, as well as where endangered species need the most help.
Hi, this is Derek, and I'm here to show you the deep learning animal classification feature for Wildguard. So we can see here if I click on this little button, it'll take us to the web page where we can upload an image of an animal. So I prepared a couple images here. Let's start with this picture of a lion. And if we hit upload and predict, the model will run and it'll return to us what it thinks the image is. So it got it right, it thinks it's a lion. And this feature can be helpful for anyone that might have a picture of an animal and they're not sure what it is. They can submit it to our backend and it'll do its best to try and identify it. So here we have a koala, a correctly identified koala. And it's also capable, you send it something that it's unsure about or is not an animal, it'll tell you. So this can of Coke says the model is unsure. Are you certain that's an animal? So it won't hopefully tell you that something is an animal when it's not, and it also won't be confident that something is a different animal than what it actually is.
My name is William Harper and I'll be showing you the population prediction model. This is only viewable when logged into a conservationist account. At the top, you can choose between different animal populations to view, and toward the bottom, you can find the historical population and 3 different population forecasts. Now I'd like to go into greater detail about how our different population prediction methods work. The first method, long short-term memory, is a recurrent neural network that is well known for being used with time series data, such as our historical population data. Our second prediction method, regression analysis, is a much simpler approach to forecasting, which simply takes the existing data and applies an equation that matches the data's trends. In practical terms, Long short-term memory is useful for populations that are currently increasing, such as the guanaco as seen here. Notice that LSTM prediction line tapers off after some time, in comparison to the regression line, which predicts that the guanaco population will expand to unrealistic levels. In contrast, regression analysis seems to better predict populations that are currently decreasing, such as the snow leopard, for example. Regression analysis's tendency to follow the trends of the original dataset is useful to ensure that a realistic time to extinction can be estimated. The blended approach is a third option that attempts to combine the two methods via inverse transform, maintaining the pros and cons of both approaches. This marks the end of our presentation. Thank you for your time and thank you for watching.